one related question is who decides, and for this issue, this point, that's not clear. That's partly what's at issue in the ongoing litigation. But so I'll talk about how we would look at it if we were the ones deciding, without making any comment about how that's gonna. But we don't know yet.
But we have to learn. We have to know how we find out.
Yes, right. But I would imagine the DEP, if they're the ones who decide in the end, probably they'll think about it in roughly the same way. It's a very case-specific kind of decision. It's how anyone here, I'm not sure we would really think about it differently than anybody here would think about a big decision where you have uncertainties. How certain do you need to feel? And I guess I use the Charles River again because we're farther along and we are deciding there, so I can be more concrete about it. We have a lot of uncertainties in how these green technologies are going to perform. We're making best estimates and we're accepting them. And we're accepting the risk that we might fall short. And we're creating some margins of safety, but we're not going overboard because the costs go way up when you go overboard. So, and we're establishing check-in points where at 5 years, 10 years, 15 years, we can either pull back or go further, depending on how things are performing. So it's not a very explicit answer, and so it may be not completely satisfying, but it's the best we can do where it's big project, lots of uncertainties, there's no way, we're only going to get more certain over time as things begin to be implemented and we see how the system responds and we see how the control techniques perform. So the best we can do is not go too fast. We need to go somewhat fast because it's a big problem environmentally, but we need to give ourselves enough time that you can implement in reasonable steps that communities can afford, that give us the time to get the feedback on performance as we move forward, make course corrections where things are working better than we had hoped or not as well as we hoped. So it's a feel our way through it kind of process.
Well, I would say that from my experience with this type of different decentralized facilities planning, there are two basic tests that I think we can say with some certainty would need to be met. The first is, is there some legally enforceable mechanism for ongoing management of that infrastructure and for correction if it fails? Absent that, regulators are right to say, no, that's not wrong. So if somebody says, well, you know, Farmer Joe's going to put in a bunch of oysters and somebody's going to do a couple of barriers at their beach house, but you don't have a formal legal attachment to the ongoing oversight of those systems, then no, it's a probably not. So those have to become formalized parts of the facilities plans. A lot of what we're hashing out in Vermont is what is the architecture of that, so that these different distributed things become legally enforceable. And the other is to ensure that there is some recoverable funding stream over time, so that we don't do what we did with the 90% grants, which is build something and then not have the sinking funds or the ongoing mechanism, or worse, what we've done with stormwater facilities in this country. So if you've got architecture and funding stream, then you've got a sense that this is going to become responsibly managed infrastructure. And I would say that those are the certainty pieces.
Yeah, I may add, based upon a few years' experience doing these kinds of projects and how they've been addressed, if you look at the practical aspects of what the town has income, you really are in a good spot. Okay, that this is at best it's not going to be done faster than 5 or 10 years. Okay, you have between now and the 2015, you can have Plan A if you will. The town has that. You then have these alternatives that over this near term, you're going to call them run to ground. They're going to be proven or disproven. So the uncertainty gets eliminated. And you put in your, whether it's done with existing management structures or you create new ones, et cetera, that's discretionary. You use real-time monitoring. We are working with some of the leading manufacturers that can do real-time monitoring of nutrients in open water and then do groundwater in one with computer models, and the groundwater models are very well calibrated. But there's a lack of data on groundwater quality, frankly, on Cape Cod. you do not have an ongoing monitoring program. And you do not have an ongoing monitoring and modeling program to get smarter about your science. So that's something that we always urge should be done continuously. So, and when you think about, you have the luxury or the inner responsibility to decide where you're going to spend, you know, you are the investor for the community at $2.2 million. You are in a great spot. You know, again, I feel, you know, congratulations on you. Have that responsibility, and my experience, again, the practical aspects are that you have enough time to develop the certainty and optimize the plant.
The standard bearer is a central sewer system. But the 30%, there's a 30% leakage factor. Now, when we talk about a 30% failure factor at that point, is that where we start as a benchmark for everything else? Plus, the occasional failure of the plant altogether, which does happen sometimes. And so we have a system that we say is pristine and wonderful, but we already know we have a third, and we live in a nitrogen sensitive area. These pipes go right along the beach. We watch the sewage, we've been watching it pop out of the pipes all along Surf Drive on our swimming beach, and it's being repaired now, fortunately. But this is the kind of thing that happens. So where is, when you think about qualifying things, let's look at the standard bearer and see where it was.
We have an urgent and immediate problem with monitoring, with knowledge about monitoring. On Monday, at the meeting of the Eco-Toilet Subcommittee of the Water Quality Management Committee, one of our main questions was, what is going to be the, how are we going to estimate the costs of putting in a demonstration project consisting of approximately 60 houses with eco-toilets in them? How are we going to do that? And one of the main questions in discovering how much it's going to cost to do that is, how much does it cost to do the monitoring? And we need a figure. So we need to come back in January to the Water Quality Management Committee and make a report on what we think it might cost to do this, so that they could fit that in. We could fit it into the larger framework of information. So we're going to be meeting on the 19th, and we're going to be meeting again probably on January the 2nd. If anyone has information for us, we would like to have that information to me. I'll give you my email address, and you come to the meeting. All of our meetings are open. All of our meetings are free. Come to us. We meet in the town hall at 7:30 in the evening on the 19th. And if you give me an email, I will be sure you get information about those meetings. So that's the first thing. The second is, at that same meeting, we had a discussion of the $6,000 credit. It appeared to us from information which we have that unless something changes in the regulations of the state, that people who install eco-toilets in their homes, if their systems have not failed, they will get no credit. That's our understanding at present, but I would like to be disabused of that. Very much. Yes.
Also, in Falmouth, cesspools are not failed systems.
That's right.
So all the people with cesspools might want to change to composting toilets, get the $6,000 credit, get the incentive that we're planning to give, $5,000, and
they cannot get it at this point.
They cannot get it because the
town
cesspool.
ordinance?
Yes.
Okay.
Yes. Some towns on the cave cesspools are failed systems by design, even if you can work with them. But in Falmouth, they're not failed systems.
Well, that's a local rule
Yeah.
That could be changed.
That's
Yes,
But there's many issues like
we have begun to identify one after another small rules that would have to be changed if we wish to do what we want to do, and that is a task that we have before us.
But that makes it really hard for a lot of people that would not be able to afford to make a change unless they have really good incentives to make it affordable. And incentives is everything to make this work. We have to have incentives.
I thought one of the really exciting things we heard multiple people this morning mention was that human waste could be an energy resource and that would be a major revenue stream, and that's not something that I've been hearing in the Falmouth discussions this afternoon at all. And so I'm wondering, hearing from either Falmouth committee members or from those of you from out of town, how that could be incorporated into the Falmouth plan. You know, because the way it was presented this morning, that makes the finances a lot more palatable when suddenly this nitrogen problem is actually an energy source and revenue stream.
You need to deal with the technology and the cost effectiveness of the technology. And I am not aware, and we've dealt with this for 30+ years, I'm not aware of small scale biogas recoverable cost effectiveness. That the rules, I frankly asked this question of a company that provides equipment. Their rule of thumb is you have to have a centralized treatment plant of a minimum of 300,000 gallons a day. So small scale systems, and I can get into the technical discussion with you why. Biogas recovery on a small scale basis is not cost effective. Microbial fuel cells is where the future action is for energy recovery, but it's emerging technology. That's really where the action.
This is probably the question that I was here today to answer, since I work in the Energy and Climate Unit at EPA with wastewater treatment plants. That's what I do all day. So Pio's right. In the typical consulting world, if you go say build me an energy recovery system, the minimum at 300,000 gallons is actually pretty small. The technologies are out there though, and they're advancing quickly. But there are research needs, which we have Office of Research and Development people in the room, and we have people like the CIWT, did I get the order right? You know, organizations like that can promote this. But it's going to have to be one of those things where you decide in your many different things that you're doing which ones you want to do energy, because there will have to be some centralization of the waste. And whether that centralization comes from picking it up in biodegradable bags and trucking it to a digester, or using a vacuum sewer and having a separate black water pipe and sending it to someplace, or collectively taking sludge from a number of small sources and putting it in one big digester, or feeding in fats, oils, and grease from your restaurant industry. And I know there's a lot of fried food here in the summer. Or stuff like that. You're going to have to do that, but it's something you'd have to build in. But it's worth definitely exploring. It's not going to pay for everything else, though.
And what about the recovery of the nutrients? Because that's the big issue here anyway.
Well, if I can expand on that. The nutrients are largely in the urine, and so it's going to depend on what you put in earlier. So if you go to urine diverting toilets, actually the nutrient recovery will be really a lot easier. And if you can find some way that you have a urine diverting toilet in a little storage tank and a truck that comes around and takes all the urine away once a month or whatever, you'd have a great system for nutrient recovery. If you build a centralized sewer system where it's 1% of urine and a whole bunch of clean water, and you're trying to get the nutrients back out of there, then it's a real pain. So it's what do you design in at the beginning that you want?
I mean, there is another twist on that too. You could have so-called smart sewer, which may be taking black water during certain hours and can be switched over to harvest the yellow water from storage tanks in people's households for the other time. And so you could still keep them separate if you wish to through a smarter sewer operation process, which these days is not a big technological problem. It's just a small storage tank that has a solenoid valve on it, gets switched over at certain hours. So, I mean, there are a whole suite of possibilities. This is the point I was trying to make earlier. It depends how you frame the problem. And we're thinking of it against a traditional sewer mentality. Yes, you need almost hundreds of thousands of people to make it worthwhile for energy recovery. But if you're going for a black water recovery, and if you're going with other food residuals, either from the home through the same black water sewer, or from restaurants and or other sources, so curbside pickup being one of the obvious ones, yeah, as Jason was saying, there are suddenly a whole suite of other opportunities emerge. So you need to look at this problem as a whole problem. So it includes curbside compostable garbage, so-called waste in some people's minds, etc. And it needs to be coupled with food production. So what are the local agricultural requirements for nitrogen? Based on a life cycle assessment for what we did in the Swedish program, you could cart for about 200 kilometres from your source and still be cost effective ahead as a fertiliser in the sense of the energy and so forth entailed in that. So, you know, what are the local agricultural requirements or potential new industries you could develop in this area is another way to look at it.